Okay. Uh, so guys, good evening. We shall resume from where we ended, or we can decide it to, yeah, from where we ended. Okay, someone has suggested we'll repeat our subnetting. So let's go back to slide 26. Okay, so subnetting, subtopic subnetting. Let me see if I've unmuted myself. Okay, let me first clear this. So subnetting, I said, if you remember, let's do this using an example. If we have a network of class C, let's say we have 172, no, that's class B, 192.168.10.0/24. So we say that part of this network is network part, then the other one is a host part. So because I told you if they just slash 24, those it means 8 multiplied by 3. 8 bits in each octet, because there are 4 octets. In each octet, we are having 8 bits. 8 bits. 8 bits. So this is a slash 24, meaning from here to this side, that's the network part. The host part starts from here. So if we look at this one network, your network engineer, you've been given this network to assign it to a company. Let's say if a company has just only one department, we would go ahead and calculate the number of available IP addresses that we can give the hosts. And how shall we calculate? I told you this first address here, the first one, 192.68.10.0. It is our network address. It is our network address. Wait. Not seeing my screen. Let me reshare. Let me stop sharing and reshare again. Someone said they are not seeing my screen. Can you guys now see my screen? Someone say yes. Can you see my screen? The person who was saying was not, couldn't see my screen. Let me see who was that. Dale, it should be your network then. If you can't see your screen share is loading. Okay, they're telling me it's loading from this side. Is it my network is very strong? How about any other person? Let me see. Nelson, can you see my screen?
I was seeing, but now it's lost.
Oh, wait. What's happening? Okay. So as we wait for the screen to load, from this side they are telling me it's loading. So let me be discussing. I told you subnetting helps us to create small networks within a bigger network. Because as I've told you, in one network, you have what you call a broadcast. Whenever you're sending information and you want to reach a particular person in that network, what happens is we first flood the packet to find out the physical address of that destination of that receiver. So if we have a very big network, meaning we shall have a lot of traffic moving within the same network. Yes, and at the end of the day, you shall have congestion, like a lot of traffic. We call it overloading. A lot of traffic will be overloaded on that big network. So what they decided to do is to come up with subnetting. Subnetting, you're coming up with small networks, depending on the needs of the company or depending on the needs of whichever customer it is. They may want to have small departments, or they have small departments within their network, and they wouldn't want one department to share information with another department. You get, so it creates small networks, subnets. You get, call them local area networks. So what you do with subnetting, you as a network engineer, they will give you a network address for that particular university or campus. You get, or company. It's up to you to now divide into small networks, depending on the number of departments you have, or faculties you have. You get. So they will give you. Let me now start. I'm sure now you can see my screen. Let me see. It's 192.168.10.0/24. So if it is one network, that's the network, and we have no departments in our company, we shall just say, now the very first one, the 192.168. The very first one. Oh, wait. Oh, that's so big. The 192.168.10.0 becomes our network address. Because remember, we told you that for network address, all of them will be zeros. And this is a class C. This one here, the first one, the network address. So how we represent that last one? Let me show you, because we saw that this is the host part. The host part starts from this one here. So we are representing that with a .000000. There should be 8 zeros because there are 8 bits. I think one more zero like that. So how do we represent the network address? We shall put all ones. So it will be 192.168.10.255. That's the broadcast address. But how do we represent it in terms of bits? We represent that with, now in the host part, we shall have all ones. Because if you add all those numbers, you end up with, you remember these numbers where we calculate these IP addresses from 64, 32, 16, 8, 4, 2, 1. So if we want to get to 12255, we add all these numbers. That's why we are putting one ones like that. For 0, it won't have anything. For 0, it will just be 0, 0. Hope this one now is making sense. 0, 0, 0, 0, 0. Now, how many available IP addresses? How do we calculate the number of available IP addresses? Available IP addresses that we can address to the hosts. So we shall have 2 power the number of host bits. Host bits, you're counting the bits in the host part. I've told you this is the network part. The host part starts from here. And you have to count this host part here has 8 bits. So you get 2 power 8. Let me see which side can I use here. 2 power 8 minus these ones here which are not needed, the network address and the broadcast address, because they're not used. Remember their function in the previous classes. So minus 2, what do we get? 2 power 8 is what? What do we get there? It will be 128, right? 2 power 8, what is 2 power 8? And someone to quickly tell us.
256, I think.
256. Now, yes, 256 minus 2, meaning we shall have the number of available IP addresses as 120. Wait, 254.
254.
Yes. So hope now it is clear. That's now if we are doing no subnetting, we have 254 IP addresses, but meaning these 254 IP addresses or hosts, they are all in the same network. They are all in the same network. So meaning these people can reach each other. Now, what if this company has 2 departments or 3 departments? You get? So if it has two departments, let's assume it has two departments, meaning we need 2 networks or 2 subnets within the same network. What do we do? It's what we are going to do next. Let me first clear this. That's if it was a company that has no department and all the people in that same network can communicate to each other. Now, what if we have 2 departments in the same company and we want these 2 departments to have different networks? What do we do? Now we bring what we call subnetting. What happened with subnetting is what we are going to do right now. So we have you as a networking have been given 192.168.10.0/24. So using the knowledge of subnetting, your network engineer should be knowing how to subnet. So what we do, I'm going to leave out this network part. I told you /24, and we are going to focus on the host part. Now the host part, if we represent the host part in terms of bits, we shall have dot 0, 0, 0, 0, 0. There should be 8 zeros. Hope there are 8 zeros. Yeah. So we are focusing on the host part. If we want to get 2 networks, what do? We shall use one of the bits in the host part and change it to 1 because we are borrowing, we want a network bit. So we create here a 1 and the rest have to be zeros. Like that. Because how shall we calculate the number of subnets, the number of networks that we need, the subnets? Meaning we shall look at 2. Now it's the number of subnets. I've borrowed 1 bit from the host part. The number of subnets or number of networks, number of subnets. It will be now 2 power. This 1 bit here, it's only 1 bit, 2 power 1, and we shall have 2 subnets. There are now 2 subnets. Do you get the point, guys? We have 2 subnets, call it 2 subnets by borrowing the bit, meaning the network now ceases to be a /24. It's going to change to 192.168.10.0/25 because of this additional bit. So from 24 to 25 now. Guys, are we together? Are we up to that point?
Yes,
Hello.
we are together.
So meaning this is my subnet 1. This is the first subnet 1 or network 1. If it's a department, we can call it now department. Department A. How do we get the network address? Because this one is now a full network, but how do we calculate the network address for now department B or subnet 2 is what we are going to do. Now from this we are going to focus on this new network that we have created as a result of subnetting. Now, if you are to calculate the number of IP addresses for this network, we shall count. Now, remember you've taken this off. So meaning the available IP addresses, they're going to start from here. They are now 7 bits instead of 8 bits. Now, the number of available IP addresses now for this particular subnet. Number of available IPs, let me just put IPs, will be now 2 power 7. Remember the minus 2, because in each subnet, in each network, we shall always have a network address, which is in this case, this one itself. And what? And the broadcast address. So meaning 2 power 7 is what?
2 power 7, 128.
Now minus
128.
Meaning we shall have 126. Are you getting the point, guys?
126.
Yes.
Those are the number of available IP addresses. So, but 128 represents all the IP addresses minus you subtracting. So, meaning from this network here, this one here, we are going to add. Now that one becomes like a network incremental, and let me call it incremental value. For you to calculate the next, you want to know the next address for subnet 2. How does it look like? So the incremental value will be 128 if we haven't subtracted. Do you get the point, guys?
Yes.
So meaning if it's 128 from 0, now my subnet 2 will be 192.168.10. Now from 0 to 128, that's the incremental value you've calculated. Slash, don't forget slash 25. That one becomes my department B. So meaning, if you look at this very carefully, it means in your first department or subnet 1, this will be the IP address you'll be giving to your people. 192.168.10. Remember, we don't assign .0. It will be now .1/25. You give it to host, maybe host 1. Now you remove like that, up to the last person, because you have 127, 126 available IP addresses, meaning those are 126 hosts, up to 192.168.10.126/25. That's the last host 126. Keeping in mind that you've put 192.168.10.0 off as a network address, because you can't assign that. It has its purpose, it's representing a network ID. Then you also remember that here you're putting .127 off, because the last IP address here, which is the broadcast address, will be now 192.168.10.127/25. This is the guy that is off, which is a broadcast address. Yes. Now for department B, let's do it here also for department B. We are now on department B. Let's calculate for department B now. But now remember that these things keep on increase. Like if you had to observe, you see 127 is the broadcast address. Now from the broadcast address to .128 without you subtracting this one here becomes the network address for that. It's not always 0. You find this in subnetting. Without subnetting, you are declared that it is always .0. But now this time around, this /25 becomes my network address for the department B. It's where we are starting from. Meaning the next address for this guy, it will be now 192. 192.
Mr. Emma.
Yes, yes.
Yes, I'm requesting for some light. I've forgotten about the /24 and /25. Probably you can help me just in a brief 1 minute of just giving me some light how we come with the 24 and 25. The /24 and /25.
Okay. So you can see this text of this one where I'm putting my cursor, this one here. Can you see it?
Positive, yes.
So we have .0 here, /24. But that is the network without subnetting.
Yes.
Now, what we do if we are doing subnetting, we make use of the host part. I've told you for class C, the host part starts from here. Oh, sorry. Let me rewrite this. It was 192.168.10.0/24. That's now the class C network without subnetting. But in this class C network, these first 3 octets belong to the network part, and we have only 1 octet in the host part.
Positive, yes.
Yes. So now we are going to focus on the host part because the host part where you find the IP addresses to use. So from the host part, you realize that these ones are represent them in bits. We shall have .0, 000. There will be 8 zeros. Those are terms of bits. These are the bits we have.
Yes.
But now if you're doing subnetting and you want to create different subnets or different networks, different subnets, you borrow 1 bit because you want to create 2 subnets or 2 networks. You borrow 1 bit from the host part. By borrowing, you're going to do this. You're going to make the very first host bit to be a 1, a network bit like this. Now the rest will be zeros like that. So meaning now the slash that the mask ceases to be /24, it will be a /25 because there's another additional bit here.
Yes,
remember, /24 comes as a result of getting 8 bits plus 8 bits plus 8 bits. That's now /24. But now this time around, you're getting all of these bits, which are 24. You're adding another bit, which is now becomes now /25. Now, meaning now your focus is no longer on this network. Your focus is on a new network you've created, which is 192.168.10.0 like that. But it's
yes.
Now for when you're calculating, you know that now for this, if I'm calculating the number of available IP addresses, it now will be 2 power 7 because the other bit is now a network bit. You're no longer counting it.
Yes, absolutely, yes.
Yeah, but we are subtracting what we don't use, the network address and the broadcast address, to get the one we got.
Yes.
What we got 126.
126, yes.
Yeah, so now that's how we get the /25. The meaning this one is representing the first subnet. You get?
Okay. Now I get you. We can continue.
But guys, when subnetting, I'm doing this from experience because I know I've told you that in my company I have 2 departments. So in my mind, I know to get 2 departments or 2 subnets, have to get 1 bit because it will be 2 power 1. So let me just complete this number of subnets now.
Yeah. Good.
Number of subnets, it will be now 2 power 1 to get 2 subnet C, and this is the first subnet 1. And how do you get the subnet 2 now? Now back to where we were. How do you get the subnet 2? How do you calculate it? Now you get this 2 power 7. You get the incremental value. You just get 2 power 7. Wait. 2 power 7, which gives us 128. So the incremental value is 128. So meaning from my next subnet will be 192.168.10.128/25. Like that becomes my subnet 2. So I was emphasizing this, that you've seen from the first, without subnetting, the network address is always .0, but with subnetting, it can be even any other value. From our calculation, you now realize that .128.128 is a network address for this subnet 2, meaning 192.168.10.128 becomes my network address for department B or subnet 2. Now the rest number of available IP addresses, it will be the same like the previous one. Available IP addresses, available IPs. It will be now 2 power. Wait. 2 powers. Yeah, 2 power 7. Because minus 2 exactly. Which will give us still 126. But remember that now you're going to get 128 plus 128. What do you get? 128 plus 128. What do you get again? You get what?
56.
That's what do you get?
Pardon. Like, what are we adding?
I've told you, if you, okay, let's observe the previous example. You observe that for subnet 2, we got 120 as the incremental value, but the previous address is the broadcast address. Do you see this? Where I'm putting my cursor, this one here.
Yes, we see.
Yeah, so 128 is the network address for the network, but the previous value 127 is the broadcast address. So I'm asking here, 128 plus 128, what do you get? 256, eh?
Yes, it's that.
Minus 1, meaning it will be now 255 like that. Anyway, I think I'll end here for subnetting. You guys look out for my examples to understand these things very well. Eh? I think, Sebuli Badeo, are we fine now? Are we fine with subnetting? You made me rebound. Eh?
Yeah, yes, we are now. We are.
Okay.
Yes, we are fine.
So now in this particular, they're saying why subnetting? We realize that now for this particular slide, they use the class B .16.0. There is the class, a class what? A class B. And realize that on calculating the available IP addresses, this is the number. These are a lot of people on the network.